Banhiman. Banhiman. What's your profile, Banhiman? Okay. So Banhiman, there is a mic symbol. You can unmute yourself and you can talk. All right. Let Banhiman figure that out. Mehnaz. Mehnaz, can you hear me?
Hello, sir. Good evening, sir.
Hi, Mehnaz. Good evening, Mehnaz. What's your profile, Mehnaz?
Sir, I'm a student and I'm currently pursuing masters in economics, and my results are not out yet. And I'm a
But you,
fresher, sir.
yeah,
Sir, can
final
you hear me?
semester of MSc.
Yes, sir. Yes, sir. Yes, sir. And we are not sure about the exam that is going to take place or not. So we just gave an internal exam, waiting for the results to come out. And our semester 3 results are not out yet. So right now we are waiting for that. And freshers, I'm a fresher, sir,
Okay,
and
good
want to
to know.
learn programming languages.
All right. Nandini, how about you?
Good evening, sir. I'm also a pursuing economics from CU. I have just completed my first sem. And I
First,
also want to learn
masters
the
or
programming language.
undergrad?
Master's MSc. I just have
Great.
completed the first sem only.
Perfect time to
And
do
it's,
it.
so sorry, sir.
I'm saying, to do a vocational program on data science, this is the perfect time. The reason is that then you also get an opportunity to apply for internship projects before you apply for your final job. So that is
Yes,
why
sir.
I
I
say
also
that,
think this is very uncertain about the masters right now. So I'm also interested to learn the language.
all right. Raghavendra BN. Hi, Raghavendra. What's your profile, Raghavendra?
Uh, Hi, Pratik.
Hi.
Good evening.
Good evening,
Actually,
Raghavendra.
my background is in mechanical engineering. So
Okay.
I'm working professional. For the
Okay.
past 10 years, I'm working in, I entered in CAD design.
Okay.
So I work for like design and maintenance of aircraft. Like I was partially working for design,
Oh, yeah, I
CAD
remember
design.
seeing your profile. Okay.
Yeah.
Okay. Okay.
So that's what now the industry is not that fast as it was before.
Mm-hmm.
So I just want to see how I can identify myself in data science and what's the potential for like this.
All right. Okay. All right. Thank you, Raghavendra. And
Yeah.
then do we have Ramesh? Hi, Ramesh.
Yeah, hello sir. Myself Ramesh. Currently, I'm working with Accenture. I have 7+ of years experience in Oracle EB Suite as well as Oracle Cloud ERP. I'm in main into finance and SCM modules. Yeah, I just wanted to learn how the analytics will help my domains and technology.
So are you planning to change it, Ramesh? Are you planning to go away, I mean, get out of EBS, Oracle EBS?
Yes, if I get an opportunity, I'll definitely change my technology. Currently, I have a certified Oracle Cloud Financials.
Okay.
Even Oracle also have analytics as well as machine
Yeah.
learning.
Mm-hmm.
Uh, but that has been developed by Oracle itself. So I
Mm-hmm.
just wanted to understand the technology and all everything in the analytics side.
Okay. Shayantika?
Good evening, sir. Sir, I'm also a student and I'm currently pursuing masters in economics from Calcutta University,
Okay.
and I'm a fresher. I'm also a
All right.
fresher.
Thank you. Soham?
Hello, sir. I am an economics honors graduate. Currently, I'm pursuing masters in Calcutta University as well, and I'm also a fresher.
Okay. And Shweta?
Good evening,
Shweta?
sir. I have done with my MBA. I worked in Cargill Business Services. I have 1 year of experience, and due to maternity, I have resigned my job. Now I am looking into this data science in order to improve my skills.
Okay. And which city are you from, Shweta?
Bangalore, sir.
Bangalore. Raghavendra, which city are you from? Pune, is it? Or Bangalore?
I'm from Bangalore, sir.
Okay. And Ramesh, where are you from?
Yeah, I'm from Bangalore.
Okay. Naveen Kumar. How about you, Naveen?
Sir,
I think.
I'm from Bangalore, sir.
And what's your profile, Naveen?
My name is Naveen Kumar. I've done in BE Computer Science. Now working as a system engineer in IvyProSchool Systems, sir, in Bangalore.
Okay. For how long?
1.5 year experience.
Okay.
Now
Okay.
I'm interested in coding.
Okay. All right. Thank you, guys. So thanks for the quick profile. Although I did have your profiles with me, but I just wanted to verify that because at times some of the people are there, not there. So I'll also quickly talk about my profile. I am also a BE in computer science, but that was a long time ago, late 90s. And I've also done my MS in information systems and operation research. That was in also in early 2000, and I did it from Texas, US. And then I worked as a consultant, financial technology, financial data consultant for some of the big five consulting firms based out of New York, Chicago, Washington D.C. area, Houston. And then so I've got around 15, 16 years, 16 years or so I've spent in the industry. And in India, I have consulted wide variety of companies ranging from the largest manufacturer of steel like Tata Steel to ITC to Honeywell, to Capgemini, Cognizant. I mean, wide variety of companies, HSBC and whatnot. So I call myself as a problem solver. I don't call myself as a Python coder or even a data scientist. I say that I'm a problem solver because ultimately data science should result into solving problems. Okay, we use data to solve a problem. You see, when data science was not very famous, then it's not as if problems were not getting solved. People used to use their experience and intuition to solve the problems. But now, because we have access to a lot of data, so what people do is that smart people, they say that, hey, you know what, we will not just rely on our past experience or intuitions because they can be wrong. We will actually rely on hard facts, right? And that's how data problem solving has come into being. And that is why we also call it as a decision sciences. And that's the first term that I had heard when I had heard about data science, which was back in 2003. One company had come to our campus in the US for an information career session. The company's name was ZS Associate. They're called as ZS Associate. And it's now there in India as well. And one of the founders, there were two main founders. One of the founders was an Indian. So he said very nicely, he gave us a very short speech, and he said, you see, we all use data to make decisions, we just don't realize it. For example, you have to decide which clothes to wear today. You decide on the basis of what the weather is outside, who are you going to meet today, what is your plan, what did you wear yesterday, what are the kind of clothes you have and accessories you have. And that's how, so based on the hard facts, even though your mind is doing all these analysis on the basis of facts and doing it very quickly, so you don't realize it, but decision or data sciences is something that is going to touch everybody's lives. And if since we were doing MS in information systems and operation research, so we had to work with a lot of IT systems and data as well. So he said that it makes a lot of sense to be in decision sciences, right? So anyway, so what I'm trying to say is that decision sciences at some point of time became, if you look at the evolution of these words that we keep hearing, decision sciences became analytics when somebody started saying that let's apply statistics to data, right? So that's when it became, or analysis using data or analysis using statistics, so it became analytics. And then a lot of people started then calling it as a data science when when they said that, okay, analytics is statistics, analysis of statistics, or mathematics, or application of mathematics and statistics, and you include computational science. That means computer science, a little bit of computer science into it, and that's when it becomes data science. So that's how these words have evolved. But you see, I mean, the way I look at it is that ultimately it is about making decisions or solving problems. Okay, so that is why good data scientists are those folks who are good problem solvers, right? So that sets the agenda for today's session, that how do we get started with the data science career. Okay, of different profiles. As we see here, we have got people who are freshers, we have got people who are experienced, people who are from economics background, people who are from engineering background, so various different fields. At times we also get commerce folks as well. So how do people from various different backgrounds make a career in data science? And feel free to ask questions at any point of time. You do not have to really wait for the questions to ask. So this is the agenda that I decided, but you can always, this is very flexible agenda. We can always do plus and minus here. So we'll talk about what data science is, how do we want to define it. We'll also talk about, this is one of my favorite things that I do, is that since a lot of you guys are young, so I would tell you, what could be the next what could be the next idea for $1 billion startup, right? I mean, how do these companies are making these $1 billion products, right? So we'll talk about that as well. We'll see if we have time for business case study or not. And we'll also talk about some of the things that the interviewers like to focus on in data science interviews, so that you guys also get some idea as to what is it that you're preparing yourself for, right? So what do they look for in a data science interview? Okay, and then if you have any specific question about data science industry, I'll be more than happy to take it. Okay, now, so the first question is, what is data science? So first look at this picture and tell me what is the difference between the images which are right over here and the images right over here. What do you think is the difference? What do you guys think? Any what do you think, guys? Any thought that comes
So
to your mind?
the above three items are analog devices, whereas the below three are digital devices.
Okay, okay. So above are analog, and then the below are digital. Okay, analog and digital. All right. Anything else that comes to your mind?
They require charging because there's no battery in analog and there's a battery in digital.
Okay,
Electro-
battery. I mean, the watches could have required batteries as well, but what else?
It's more than the intended purpose it serves.
Yes.
Okay, it serves more than the intended purpose. All right, good, good. You see, these devices, the second set of devices, these devices, they recommend decisions. One of the very, very important thing that these bottom devices do is that they recommend. Meaning what? Your smartwatch recommends you that, or maybe your wearable, say for example, this Fitbit or wearable healthcare device will tell you that, hey, it's time to walk. You've been sitting for a long time. It's time to walk, right? It's a recommendation. And how did it know? Because you see, it has seen your pattern and it has seen that you have not moved much. So it pings you that, hey, it's time to move, right? So it's a recommendation. Your smartwatch recommends you that how many calories you have burned, or that you've been using your screen for far too long. Right now, nowadays all the smartphones have this feature that they recommend for how long you've been using a screen. So this recommendation is basis. How are they recommending? This devices are recommending how are they recommending it, these decisions? How are they recommending these decisions? What are the basic component on the basis of which they're recommending decisions? What do you guys think? Durgesh says by ML algorithm. Okay.
Input we feed.
Input data it captures. Okay. So they recommend on the basis of data. They capture data and then they analyze that data using some machine learning algorithm or statistical algorithm, and then they recommend decisions. So this recommendation is basis on the data, right? So that's why we call them as a smart products, right? Because they recommend, they have smartness or artificial intelligence in it, right? Which these devices did not have. That stethoscope of old age would not have told you that your heartbeat is fluctuating, even though it has understood. I mean, it has, because it never used to capture any information. But now these wearable devices, they capture your heartbeats as well, the pulse rate as well. So they can actually tell you that, hey, you know what, you have X% of the chance of, some heart alignment. So heart ailment. So the idea is that you got to do something about it. So that's a recommendation basis data. It's not very difficult, right, on today's world. So what is that? What is that equation or a model, if we were to say, or a formula which creates a smart product? Okay. So let's look at this formula that I've kind of devised. Look at, so if you have to make a smart product, right, which could be a next $1 billion product idea, right? What are the 4 components that you need? For example, we all have fans at our home, right? Now fans are pretty dumb. Why am I saying fans are dumb? Because you see, my fan, I have to operate it. I have to decide at what speed should it run at, right? I have to adjust the speed. Whether the temperature is X or Y or Z, how many people are sitting in the room, it doesn't matter. I still have to go and adjust the fan speed, right? The fan has been with me or have seen me using it for so long. So if they would have captured the data, they could have made that decision by themselves that, hey, since there are 3 people, the weather outside is whatever 34 degrees, so I should run at a specific speed. The humidity in the room is X. So do you understand what I'm trying to say? The fan is not smart. But if you have to make a smart fan, what would you do, right? So you need some kind of a Wi-Fi chip, which costs typically less than $2, right? To embed with the fan and make it connected to the internet. The moment it is connected to the internet, what happens is that now the fan, and so Wi-Fi chip plus some sensors. One sensor could be the weather sensor, the temperature sensor, which is very easy. Thermostats have had for a very, very long time, right? So one sensor could be the thermostat sensor, right? The temperature sensor. The other sensor could be the object sensor, which is also very, very easy. Your phones have it. It's not a difficult thing. So you have a couple of such sensors and you have a Wi-Fi chip enabled. Then what happens is the sensors, they are supposed to sense data, right? So they sense things and then they generate data. That data needs to be stored somewhere. And where would that data be stored? In a cloud database. Now, what is a cloud database? Say, for example, you all must have used at some point of time Google Drive, right? So where is that? When you store something on Google Drive, where is that data stored? Somewhere in the internet, in a data center, right? Somewhere remote, maybe a data center in Virginia, in the US, or some data center in Chennai. But the data gets stored somewhere there, right? In a remote data center, right? So we call it as a cloud database, right? So the data, instead of getting stored locally in the fan, right? The sensors which sense the data are sent, because it is connected to the internet. So the data is sent to a cloud database, right? So cloud database is used for storing the data. Let me know if any of these things are not making sense to you. Okay, I mean, I'll be more than happy to go into the details of this as well. Now the data is getting stored in the cloud database, right? And you, as a user of that fan, normally you have an app or a portal by which you can see the data that is getting generated. So if you have used your any health app on your smart watch, or on any wearable watch which gives you the number of footsteps that you've taken in the day, you can see very nicely, it gives you the data, right? So you have an app, a user, very nicely designed app which has a great UI user interface into it. So now you have an app to control, to see the data that is getting displayed, to see how the functionality and everything, to operate it, right? Then the main brain, because a fan has to recommend some decisions. What the smart fan, what kind of decision would it recommend? What kind of decision? Since it is connected to the internet, it can. So what kind of data would it have, right? It would have the users data, like for how long and when, right? Like for how long, meaning say at 3 in the afternoon, I like to put the fan at speed number 5 at maximum speed in the month of, let's say, June, July, and August, May, June, July, August, right? When the temperature outside is X, right? So it has users data, and then it can capture. So it is, since it is connected to Wi-Fi, that means it is connected to the internet. So it can easily capture the outside weather on that particular time of the day, right? And then it can easily capture the number of people in the room, right? So past uses, weather, number of people it can capture. Then that data is getting stored in the cloud database, right? And then comes data science. In data science, what we will do is that we will take all this data, right? And we will say that the fan speed, the one of the decisions that the fan has to make is, one of the decision, I would say this is not even recommendation, the decision that the fan has to make is what, at what speed should I run, right? So speed is a function of what? Speed would be a function of uses, weather, W, and number of people, P. Speed is a function of these three variables. You understand what I'm trying to say, right? And once we are able to establish this relationship between the speed, which is the final recommendation or final decision, with these variables, and what are these variables? Uses, weather, outside weather, and the number of people in the room. And if we are able to establish the equation, then we say our model is ready. Our data science model is ready. This model is not the same model which walks on the ramp, okay? This is a data model. This is a data science model, or a DS model, or analytics model, we'll say, which shows the interrelationship between independent variables and a dependent variable. This is a dependent, we call it as a dependent variable. The reason is because it depends upon these three independent variables. Okay, guys, I know I'm going into a little bit of details of data science, but this is not very difficult to understand. You understood, right? What is a dependent variable and what are independent variables? Independent variables determine the dependent variable, or in other words, the dependent variable is dependent upon set of independent variables, right? So speed is the decision that we have to take, and which is dependent upon the users, weather, and number of people. And that model is built basis the past users data, right? And that's where data science is coming to the picture. Do you understand? So the main brain behind this equation is data science, right? So this data science output is recommended or is used as a decision finally, and that's when the fan becomes a smart product or a smart fan, right? So what are the four things that we require to make any dumb product a smart product? You need a few sensors and a Wi-Fi chip to connect it to the internet, right? Sensors to sense the data. Internet, why do we have to connect to the internet? So that it can send the data onto the cloud database, right? You have cloud database, then you may have a great app or some kind of a user interface portal to control the device and to display the recommendations or to display the decisions. And then you have the data science models to predict what may happen in the, or how the decision would be made. If you have got these four things, right, then you can take any product which is dumb product. I mean, look around yourself, right? You will find lights which you have to control yourself. You'll find mirrors which you have to, unless you show the light to the mirror does not reflect your image. You got wardrobe which doesn't talk to you. Why can't you ask the wardrobe that, hey wardrobe, please help me decide which clothes should I wear today? Why should you have to decide? The wardrobe knows what are the clothes inside, what is the weather outside. It may be connected to your calendar, so you would know that what are the appointments you have, and who are you meeting or who you met yesterday. So if it knows all these things, then why can't it recommend you what clothes to wear, right? So there are so many dumb products around us, right, which need to be which need to be converted into smart product. And each one of these product is $1 billion worth idea. All right. So there's a computer visionary who was talking in one of the TEDx talk, and he said that I was hearing his conversation, I think a year ago or so, and he said he brought a very important point. He said the next mainstream AI product, artificial intelligence driven product, mainstream, that the entire world would be using in the next 10 to 15 years has not been even invented yet. So young people still have a lot of opportunity to dwell upon in this area. Okay, so feel free, guys, explore. If you have any if you need any such inspiration, reach out to me. I've got great ideas, but I do not have time, unfortunately, to implement, but I'll be more than happy. If you know any of these areas, if you have experience and understanding and learning in any of these areas, you have a great career opportunity. And then there are some people who are master of none, but they know a little bit of everything, and those are the folks we call them as product managers. And these guys are also important for all these product companies. They're all like Google, Facebook, LinkedIn, all of them hire these product managers, big time. Uber, Ola. The product managers, what they do is that they're ultimately responsible for ensuring that each one of these team of folks, right, I mean the IoT folks, the cloud database folks, the user experience builder, UX people, and the data science folk work together into building a ultimate smart product, right? So big opportunity area, guys. Okay, any questions, anybody? Any questions? Okay, since you guys did not ask me a question, can I ask you a question? So I told you about this model, right? I told you about this model. Can anyone give me some other example of this model whereby we have dependent variable and where we have independent variable? Where can we use something like this? Can anyone give me some example like that?
House price prediction?
Okay, how would you do that, Ramesh?
No, yeah, based on the square feet, we can estimate house price based on the locality, area, and all.
Okay, great. So house price is a function of locality. Good point. What else? Area. That means in square feet. What else? How about others, guys? Locality, area. How else do you decide a price of a house? There are some economic students, right? How about you guys? Sayantika, Soham, Shweta,
Num-
Sukan.
Number of rooms,
Okay. Number of rooms,
Amenities.
the age, the amenities in the complex. Right. So there are so many variables that the house price depends upon, right? So which is the dependent variable here?
House
house
price.
price.
This
House
is
House
a
price.
price is the
dependent.
dependent variable, and these are independent variables.
Hmm.
Are we clear on? Are we clear on this? Now, this kind of a model is called as a supervised model or a supervised algorithm. The reason why we call them as a supervised algorithm is because here there is a clearly demarcated dependent variable in a supervised algorithm. Okay, and one of I mean the most common type of supervised algorithms are regression algorithms. You have clearly labeled dependent variable, right? And then we also have something called as unsupervised algorithms. Now, let's say anybody who can give me an example of unsupervised algorithm, anybody who might have read something in data science world.
Yeah,
Okay, give me Ramesh.
classification of
Okay,
classification of
Classification. Good. So I'll just
Yeah,
write
variables.
classification. Okay. So I'll give you an example. Okay. Let's say you have. So let's say you are working with Amazon, right? And Amazon wants to understand that, hey, you know what? We launched a new Kindle. New, okay, Kindle 2020, right? Now for Kindle 2020, they do not have any past, or let's say not Kindle, because they would have a lot of data about Kindle. Imagine they launched, so Geo launched Geo Glass today, right? Let's say Amazon launched Amazon Glass, like a virtual reality glass. Now it's a completely new product. They don't have any past historical data of who has bought Amazon glasses and who has not bought Amazon glasses, right? But let's say they launch it in the market, right? And then within, say for example, within 2 months, some 1 million people buy it. Okay. Now what they want to do is that they want to classify these 1 million people into different classes. Meaning, what could be the, so 1 million customers have bought it, right? So what do you think? How can they classify their customers? What could be the classes? And Ramesh, please don't answer. Let others also answer. What do you think could be the classes of these people?
Age
How
group.
can we classify them? Okay, very good. Durgesh says age. So on the basis of
Age
one
group,
age, so
and then income group.
income, excellent. What else? So let's say age, there'll be young, middle-aged, elderly folks, right? Income, low, middle, high, right? What else?
Product.
Um, Product, okay. Maybe past product that they own. Past product meaning, do they own an iPhone? Okay, iPhone. Do they own a Samsung? Or what do they own, right?
Country
So
of
past
origin.
country, okay, right? So they can classify like this. And then for each one of these classes, so for example, this is one set of folks, this is second set of folks, this second, third set of folks, this third. So say for example, young people from India, young people from India, right? And who own Samsung. This is one cluster of people or one class of people. The second class is middle-aged people from, I don't know, from US who own iPhone. So this is class one, and this is, let's say, class two. And similarly, you may have some other classes. So class one, class two, class three, class four, and something like this, right? Why do they want to know about these classes? What will they do? Here in a supervised algorithm where we had a clearly defined independent variable, it was very clear what we wanted to do. We wanted to predict the house price based on the independent variable. What do we want to do here with by classifying this data into multiple classes? What will they do with it? What do you guys think? What will they do with it?
So they
So
will analyze the data regarding which class is buying the most of the product within a specific
okay,
period of time.
okay, maybe, very good point. Maybe this class of people have bought 33%. This class of people have bought 20%. This class of people have bought 17%. This class of people have bought whatever, right? So then they can, once they have understood what class of people have bought, they can define specific marketing campaigns for them. For example, when they have in India, they will target young folks who are Samsung owners. So maybe when Amazon is selling Samsung phones, they can create a combo. Like in Amazon, you see those frequent combos, right? That is again based on the past data, that people who generally buy Samsung and are young and are from India would also be interested in buying Amazon glasses. Do you understand what I'm trying to say? So that's how they can use it, right? And it would help them promote or come up with relevant market discounting campaigns, marketing campaigns, right? Will be extremely targeted rather than doing a marketing campaign which is generic. They can actually create marketing campaigns which are very, very specific. Do you understand what I'm trying to say? So in supervised algorithm, you have labeled dependent variable, meaning identified dependent variable. In unsupervised algorithm, you do not have a dependent variable, right? What you have is what you are doing here is that you're dividing them into clusters or classification. So one of the very famous model here is called as clustering. Okay, these two, regression and classification, these two models are used in 80% and above of data science case studies, or in solving 80% and above data science problems. So if you can master these two, then you know what, you can fend off 80% of the question that could be asked in the interviews also. Okay, now you see, we just finished one very large long consulting engagement with a company called as Tesco, which is like Walmart of Europe, one of the largest retailers in the world. And so there were 100 people who we were coaching there, and all these guys were data scientists helping Tesco make informed decisions and so forth. So in the entire program, we only focused on two models: regression models and classification models. Okay, and we are talking of this multi-billion-dollar industry, multi-billion-dollar company. We also coached last year. We coached a company called as Honeywell, very large Fortune 50 manufacturer of the world. There we trained some 400 folks. There also the main focus was on regression and classification. So what I'm trying to say is that although the data science world is huge, it's like an ocean, but there are certain drops which are extremely important than the rest of the ocean. Okay, so in our program also we try and focus a lot on these two techniques, at least at the bare minimum, because we know that especially from young data scientist folks, these two are extremely these two are expected. A lot of people get driven by deep learning concepts and so forth, but remember, it's like a ladder. You cannot jump couple of steps here and go from here to here. Never do that, because the interviews always start from here. Okay, and most of the time the interviews stop here only in the first two steps. The reason is that in the interview they're looking for people who can learn quickly, quick learners. So if you know some fundamental, your aptitude is great, your understanding of the foundation is great, then they know that you will learn rest of the things. It's not rocket science. I get your point. So that is why don't do this mistake that since there is a hype about some deep learning model that you want to learn right away the deep learning model. Is it making sense, guys? Any questions? Any questions, anybody? No? Should we move on then? Right.
Yes, sir.
Yeah, Ramesh, go ahead.
Sir, which language is suitable for if we start machine learning or data science?
Which, sorry, I couldn't understand the question. What is Ramesh? What did you say last?
Language, programming language. to
Oh, the
start.
language. Okay.
Yes,
So I'm going to come to
for
this.
machine learning.
So that's the slide that we have right now in front of us. Okay. Because this is a very common question that people ask me, that what is the right language to learn? Okay. You see, in my own experience, Ramesh, since you picked up this question, the first statistical language that we worked upon was SAS in 2003. Okay. The reason why we worked on SAS, we had absolutely no idea about decision science. I told you, right? I mean, the first time I heard about decision sciences was in 2003 by that particular company's founder. But in our university in Texas, that university had a tie-up with SAS, and so we had a course by SAS. Okay, so SAS is a popular data science company, which also has its own language called as SAS. So we did a lot of decision sciences algorithm and all of that in SAS. Okay, but then, and SAS was very popular, especially, I mean, it's still popular. I mean, but it's popular only among very, very large financial organization, pharmaceutical companies. But at some point of time, there was only SAS. There was no R, there was no Python. It was only SAS. And then, so I'm talking about, let's say, late 2010s, okay, or maybe early 2010s. So let's say around 2012 or so, R started to become popular. R was free, and R started to become popular. Around 2016 or so, 16, 17 or so, Python started to become popular. Okay, to do the same thing that we did in SAS, which is to run these algorithms, supervised algorithms and unsupervised algorithms. Okay, the reason why these tools started becoming popular, because you see the data used to be big, so people were not doing it manually, so that is why they wanted to use one of the tools. So SAS, R, and then Python. Now, what happens is, why I told you about this, this journey of tools is, tools can keep changing. Tomorrow there may be some other tool, maybe it is Elephant. Okay, and these companies have very weird way of naming their tools. I mean, these people. So, but the concepts, like the algorithms that we spoke about, like the concept of super algorithm, unsupervised algorithm, that regression, classification, prediction, those concepts remain as it is, because those are the core problem solving concepts or data science techniques. The tools are just enablers. What the tools do really? Okay, I mean, you're really not building any software using these language, as we say. They are not like C, C++, C hash, or VBA. They're not like that. They just have predefined libraries of functions. For example, if you want to run a regression model, the line of code will be 3 line of code. That's about it. Okay, and it'll have a function. Say, for example, in Excel, you have equals to sum, right? Variable 1, comma, variable 2, comma, whatever, and it adds and gives you the output. Similarly, in Python, there is a package, there is a library of functions called as scikit-learn, right? You import that package, and after that, there is just 2 lines of code to run a regression model. Just 2 lines of code. Does it mean that regression is that easy? No. The package will run regression. It will show you the output. But if you do not understand the concept of regression, right, you'll not be able to understand what is that output about. You'll not be able to make decision, which as a data scientist you're supposed to. I told you, right? Data scientists are problem solvers. You'll not be able to solve problems. You'll only be able to see, yes, it has thrown you an output, but what about this output? Do you understand what I'm trying to say, Ramesh? So the message that I want to give to you guys here is, do not run after tools. Tools are important, and definitely we, depending upon what is going on, what is popular in the industry right now, say Python and R are very popular. So we have made Python and R both mandatory in our courses. Both are mandatory. SAS is optional. If you want, if you wish, you can do SAS, but it's optional. The tools have changed over a period of time. So don't run after tools. Run after concepts, data science techniques, those statistical understanding. I mean, those algorithms that I was talking about. The tools can keep changing. Is it making sense, Ramesh? So if you really want to get into machine learning or data science industry, you want to first ensure that your fundamental concepts are clear. Okay. And I'm going to talk about those fundamental concepts as well. Just give me a second. I'll show you. Yeah. What are the skills that are absolutely must for any person who's trying to, any person who's aspiring to become a data scientist? Probability, again, part of concepts of statistics, but probability I have called out because probability is used very widely. The same probability that we learned in the school days. Okay. Statistics. Statistics that is used in data science is very application oriented statistics. For example, regression classification, all that we spoke about is part of statistics. Okay. Very application oriented. When you learn statistics now, as an adult, you will be able to appreciate that, hey, you know what, statistics is not a theoretical concept, but it's actually a very practical concept. There are a lot of economic students in this discussion today. If you ask them, they will tell you that statistics had great application in practical real world. Okay, so learn statistics with an eye to apply it in solving real problem, and then you will really enjoy it. It'll look like the most practical subject that everybody and everybody should know. And then linear algebra, specifically for machine learning, it comes. Okay, again, it is probably one of the most complex things that you learn, but it's just one concept of maths that you gotta become good at. And now computer programming, right? It's not about, you're not building a software. You don't build a software. That means you're not writing codes. You're using the code. As I said, there is a scikit-learn package library in Python. You import that library and you call that function just like how you we call equals to a sum, and it does what it's supposed to do. We're not concerned about what is the code that is running behind some function. How does it calculate this? What is the algorithm that is running behind the sum function? We don't really care. We just call the function, we write it. Similarly, in Python as well, for running regression model, there is a function available. So it is as simple as just run that model and run that function, and that will give you the output. What is more important is that how do you read that output, and that's where these two concepts come into the picture. Does make sense, guys? So you can't really skip them, right? Now the fifth thing, although I have not listed it out here, but it's very important, is logical thinking and problem solving, which kind of are the same thing. Now what is the logical thinking and problem solving, and how do companies test it? Is that I'll tell you a story, and then you'll probably be able to appreciate how they test it. So I was once asked this question: how many crows are there in New York, Manhattan area? You all understand crows, right? I mean, we all have crows in the backyard. How would you answer this question? So this was in 2003. Okay, my probably one of the very important interviews that we were having, and the question was this. Fortunately for me, the same question was asked to one of my friends evening before me, and my friend, you know what answer he had given? He said, "Sir, there are 100,000 crows." So if you are an interviewer, you will say, okay, 100,000 crores, okay, nice, but how did you estimate it, right? So the interviewer asked, okay, very nice, you sound very confident. How did you estimate the 100,000 crores? So my friend, okay, he was a little funny. He said, you know what, sir, I'm pretty confident. There are 100,000 crores. So the interviewer said, what if I go and count, and if I find less number of crores than 100,000? So my friend said, if you find less than 100,000 crows, then some of these crows must have flown flown to Canada to meet their cousins. I agree point. And if you find more, that means they must have brought some cousins from Canada to make them see Manhattan. So they had a good laugh, is what my friend told me. So, but then, I thought over, while sleeping, I thought, that couldn't be the answer, right? I mean, why would anybody ask such a question in such an important interview? if the answer was just this, right? So back then, I mean, it wasn't really too much of Google, although Google was there, but it wasn't like, you just Google and you'll find an answer. So brainstormed and so forth. Then, so the next day, fortunately for me, I was also asked the same question. My response was a little different from my friend's response. My response was that, you know what, I'm not sure if I will ever be able to calculate the exact number of crows, but I will tell you the approach that I will take, which will probably take me to a level or help me to estimate the number of crows to closest possible number, right? So I said, to in order to find the number of crows, right, we have to find the number of trees. The reason why we want to find the number of trees is, can anybody guess why would we want to find number of trees when we have to estimate the number of crows? Anybody? Durgesh, what do you think?
Yeah, previously told in this unsupervised learning, this clustering. So there's a number of trees on which the number of crows may be sitting. So you
Okay.
can count them. Instead of
Yeah. See
counting
the
the crows, it will be easy to count
yeah.
the trees.
Yes. Absolutely.
Maybe
So
based
in
on
such, yeah, Ramesh, go ahead.
maybe based on nest the
Yeah,
trees.
absolutely. So if you find the number of trees, you can find the number of nests. You can estimate the number of nests, right? And we can assume X crows per nest. That could be, let's say 4 crows per nest, including the babies, right? Now, so then the question comes out to be, how do we estimate the number of trees, right? So how do we find the number of trees in New York, Manhattan? So New York, Manhattan, I mean, again, of course, people who have spent some time there, so they would know that New York, Manhattan is actually in grid, meaning there are fixed number of streets and or crisscrossing fixed number of avenues. Meaning, it's like this. The streets go east to west and the avenues go north to south or something like that. So let's say you have first street, second street, third street, fourth street, and so forth. And then you have first avenue, second avenue, and then some of the avenues have some names as well. But there are fixed number of streets and fixed number of avenues. And at each crossing, there is a block. And in that block, there is a building. And if you're standing at the cross, suppose if you're standing here, you can see the number of sorry about that. Yeah, you can see the number of trees, right? If you're standing right over here, you can see the number of trees in the entire block. Of course, there is a building right in the center, right? So there will not be any trees there. So if you can multiply the number of avenues with the number of streets, you will get the number of blocks, right? And if you get the number of blocks, if you have ever been to New York, so you will see that you can easily estimate the number of trees in each side, because each block roughly is of the same size, because it's a planned city, right? It's like Chandigarh in India. So if you can find out the number of blocks, you can estimate the number of trees. Do you understand what I'm trying to say? And if you can estimate the number of trees, then you can estimate the number of nests, and hence you can estimate the number of crows. See, the interviewer wasn't interested in the final answer. He was never interested. He was interested in what approach, structured problem solving approach have you taken in a very unstructured problem. How have you defined, how have you put structure around it? So that's called as logical thinking, right? One of my students was asked that, suppose there are, like in India, right? I mean, it's a very common scene that suppose there are 3 pharmacy stores right next to each other, P1, P2, and P3, right? You find that there are a lot of people waiting for P2. There are very few people in P1, and there's absolutely nobody in P3. What do you think is the reason? And you are a regular visitor of P1, P2, and P3, and you live in that area. What do you think are the reason and why P2 is doing so much better? Do you understand? So my point here is that Can you think of the reason? So of course, as we said that house prices are dependent upon certain variables, the crowd for a particular pharmacy would also be dependent upon certain variables, right? And then this question led to some regression question as well, that okay, if you need more crowd, then X, Y, and Z has to be done. Maybe we give discount, maybe we build a brand that we are authentic, maybe we deliver, maybe we always have all the stock available, the largest stock between P1, P2, and P3. One of the most important thing that people, on the basis of how people decide which pharmacy store to go to, is not on the basis of the discount alone, but it's on the basis of availability of the drugs. The pharmacy store which is famous in each colony, almost there'll always be one pharmacy store which will be famous, that if you go there, you will definitely get the drug. You understand what I'm trying to say? So that is one of the very, very important parameter or a variable for a pharmacy store to have. Is making sense? So that is logical problem solving. And I tell you, after having trained more than 7,000 people personally, this is probably the most difficult thing that we find in order to train people on. Does that make sense, guys? Right? So these are the skills. Right? Now, let's go back to that slide that we were referring to. You see, you will keep hearing about these terms: big data, data management, analytics, machine learning, deep learning, and so on and so forth. So what are the differences between them, right? So when it comes to decision science, so these are some of the things which are part of decision science or data science. Okay, so you have at the core, you have something called as deep learning. Okay, now what is deep learning will come to. Then you have a layer of machine learning, then you have a layer of artificial intelligence, and then here you have something called as data visualization. Okay, now deep learning is like how our brain works. There are layers of neural networks. That means, in our brain, you see, subconsciously as well, even though we don't realize that we are capturing the data, but it does capture huge amount of data. And that's how we all build subconscious experience. For example, you have never driven a car, but let's say in a case where you're sitting in the not in the driver's seat, but you're sitting in the passenger seat in the front, right next to the driver, and something happens to the driver, you would know that okay, I have to try and pull the handbrake first, even though you have never driven the car. But your brain has subconsciously, and you've never been trained as well, but since you have traveled in the car, so your brain has subconsciously developed that experience that, you know what, in order to stop the car, I need to pull the handbrake. Do you understand? So first instinct would be that you would look for the handbrake in that unfortunate circumstance. So that is deep learning. That means we don't know how we made that decision. We do not know that how did I know that I had to pull the handbrake first? I don't know that, but my brain signaled me that I should do it, right? Similarly, what happens is that when you train a computer language, or that means when you train a computer with huge amount of data on one topic, right, then it becomes deep learning. And I'll tell you what it means. So deep learning is just layers of neural network, just like how brain cells work, right? On the basis of neurons that we have in our brain. And machine learning or deep learning models are the same, which is that it works on huge amount of data. Say, for example, you want to identify that, or you want to make a model which will identify whether an image is of a chair or not, right? Whether it is chair or not. So let's say, how would a human understand or learn whether an image is of a chair or not, right? Suppose there is a human that, there's somebody who has come from completely remote area. Let's say he's spent all his life in a forest. He has never seen a chair ever before. Now you would say that, okay, this is a chair. So what would you do? You will show this person a lot of chair images. So maybe you will go to Google first thing that you'll do is that you'll go to Google and you'll say chair images, right? And then you'll go to images and then you'll say, okay, these are all the chairs. You can see these are all chairs. This is where we sit. So that's how you're training. That's how you're making that other person who has just come out of a jungle that, okay, you know what, this is what chair looks like and this is where we sit and this is how it functions, right? So, but you see, it says what? How many images are there of chairs? 255 crore images. Do you all see this? 255 crore images of only chairs, right? Would you, to a human being, would you make him learn or would you make him go through all the images? You would not, right? You will say, okay, you know what? Let's take a sample of these images. Let's, show him some 10, 20 images or maybe even 100 images, not 225 crore images, but just show 200, some 10, 20 images. And so it's a good random sample of chairs and, the person will understand, right? But the deep learning algorithm, the way it works is that you say, because it's a computer algorithm, so you say what, computer, read or open, sorry, open each one of these 225 crore images of the chairs and using the pixels, because each image has pixels, right? The pixels which are dark, and so that's how they understand image recognition or computer vision happens, right? Make a profile of the chairs and come to a common description of chairs. Now, if a computer program has read or reviewed each one of these 225 crore images of chairs, pictures of chairs, then they would say, you know what, chairs are chairs are like this, right? Now, next time to that computer program, you say, you know what, please tell me if this is a chair or not. Now, this is a chair or not. Now, a human being who just came out of the jungle and who has seen 20 images of chairs, sample of chairs, who had never seen a chair like this, would not be very confident whether it is chair or not. But a computer program who has seen 255 crore images of chairs, right? They would have seen one such chair somewhere, right? So they would say, you know what? I am 90% sure that this is a chair. The machine model or the machine program or the computer program would say, I'm 90% sure that this is a chair. Why? Because somewhere, I can't tell you where though, somewhere I have seen this as to be the chair. Do you understand what I'm trying to say, guys? So what I'm trying to say is that deep learning is to mimic how human brains work, whereby we do the right thing, but at times we don't know why we did that, or we take an action, but we don't know how our brain knew that. It's just that it has experience, subconsciously. So similarly, in deep learning algorithm, it will say, I can't tell you for sure as to where I've seen an image like this, because they were just practically impossible to, figure out, which out of those 255 crore of images was looking like this, or maybe it was a mixture of a few images. But I am 90% sure that this is a chair. So a deep learning algorithm mimics human brain, right? It'll give you an output which will be fairly accurate. But one of the drawbacks, there are two main drawbacks of a deep learning algorithm. First main drawback of a deep learning algorithm is that it requires huge amount of data to be trained. And the second problem with deep learning algorithm is that it does not justify its recommendation. That means does not justify why it is a chair. It cannot tell you exactly why it is a chair, right? So one spectrum of data science is deep learning algorithm, whereby we almost say it's a brute force, that you make a model or you make a program learn with so much of data that it would have seen something like this somewhere for a new data set, right? Then comes machine learning algorithm. Machine learning algorithms use something called as statistics, which is statistics is a science of sample or estimate. Okay, so statistics is a science of estimation, whereby we say that if something is true for sample, like we said that 20 images of chairs look like this, right? If 20 images we saw and the chairs were like this, there was a back support there somewhere, and then there was There were 4 legs and there was a plate to sit. And this is how most of the chairs look like out of those 20 images that we've seen. So if a new chair comes, which kind of looks like this, so then I'll be happily say that, yes, this is one of the chairs because I've seen in one of the 20 images. So I can justify. The difference between deep learning and statistical algorithm would be that statistical algorithm will not be that accurate. A deep learning algorithm will be very accurate, but statistical algorithm will tell you the reason, the rationale behind its recommendation. And that's one of the main reasons why most of the large companies still prefer to use a statistical machine learning algorithm versus a deep learning algorithm. Because a deep learning algorithm does not justify, it's like a black box, it does not justify its answer. So that is why we end up using machine learning algorithm in most of the usual cases. And a couple of machine learning algorithms that we spoke about today, supervised and unsupervised algorithms, regression and classification, these are all machine learning algorithms, right? And then when you plug it with data visualization, right? Data visualization, which is like, when the election results come, or when a cricket match is happening, right? So they show very interesting results, or graphically or visually, right? Because human brain, not the machine program, but a human brain works better when they can visually see the data. See, I'm drawing all these things colorfully here. The reason is because it creates a visual impact. So human brain is very visual in nature, not the computer programs. Computer programs, for learning or creating a deep learning model, it doesn't need to see anything visually. It just gives the data 0 1 and understand. But for human brains, we also do data visualization quite comprehensively. And that's when we say that when you plug data visualization along with machine learning algorithm, so it becomes decision sciences or data sciences. And when you're just doing pure deep learning algorithm, whereby you mainly rely on huge amount of data, right? So then we say it's deep learning algorithm. Does it make sense? Combination of all these things are part of artificial intelligence ecosystem. So artificial intelligence is like an umbrella term which kind of includes everything. But remember, all these are still in a stage where people are redefining their definition. There is no Webster dictionary definition of these terms. So different people may have different interpretation, but based on my research, I found this interpretation to be a little more consistent than the other interpretation of these terms. Okay, are we clear, guys? So now coming back to this deck, you need big data because, as I said, right, if you're talking of deep learning algorithm, it requires huge amount of data. And you see what has happened is because, as we spoke about that, with the advent of so many um, smart products that we all use every day, what has happened is that all the smart products have sensors, and these sensors generate data, right? So when they are generating huge amount of data, such huge number of people are using smart products, smart devices, smart watches, smartphones. So you require an ecosystem which can manage huge amount of data. So that's when big data ecosystem comes to the picture. Hadoop is one such platform, okay, which is like a group of programs which help you to manage large amount of structured and unstructured data. Okay, then data management and data handling. Now 2/3 of your project times goes into data handling or data management. What do we do in here? So for example, you get huge amount of data, right? Suppose suppose you're working for Amazon. So let's say you have huge amount of sales data, right? And what you want to find out is that what were those top 3 products that we sold the most in the last sales season, or what were the top 3 smartphones that we sold the most, right? So that data aggregation, data segregation, merging, deduplication, duplication removal, all these are part of data cleaning. And visualization is also part of data management. So data management is a huge portion in any project. Almost 65 to 70% of time, almost 2/3 of your time, project time, goes into data management. Okay, and that's the reason why, as a young data person, you need to know these data handling skills. You need to have strong data handling skills. Some of the tools that we end up using here, SQL is very, very important. Excel, VBA, these are very important. And then again, you do data handling in R and Python and SAS as well. But SQL becomes extremely important. Excel becomes important. Tableau is used for data visualization, very commonly used. And then when you are actually ready with the data, you are in a stage where you want to now run models, right? Supervised and unsupervised algorithm. Then you use these predictive models, right? And skills here are statistical interpretation, which we have been talking about. The tools that are used here are R, Python, SAS typically. SPSS and MATLAB have become old. Not many people use it. And machine learning, as we said, right? Machine learning and deep learning, when you make computers use statistics to learn by itself. Some examples are Google Maps, right? So they again fall into a category where you're mimicking human brain with the help of machine, right? Again, not special tools are used, but combination of things. Python would also be there, a little bit of some other computer program could also be there, and so forth, right? And artificial intelligence is something which kind of encompasses everything. In a course, we this much we make it mandatory for everybody to learn, almost this much. Okay, big data does require, we recommend big data for people who are a little more tech savvy. Machine learning also anybody can learn, but not unless you have done this. Most of the interviews, okay, 80% to 90% of the interview discussion would be around here. Rarely people go to deep learning and artificial intelligence. They may, even if they ask you some things, they may ask you some fundamental concepts just to see whether you're aware or not. Okay, any questions from here, guys?
So, is data science and analytics is the same, or is there a different?
Again, so look at this. What I have done here is that, again, these are all terms which are evolving over a period of time. There's no bookish or dictionary definition of them, right? So the way I define data science is, data science includes big data, data management skills, analytics, which is nothing but applying statistics and analysis together, so analytics, and machine learning. So when you combine these, then I call it as a data science. And artificial intelligence is everything. Do you understand what I'm trying to say? So again, do not go by what do I say? Do not go by wordings here. Ultimately, you are trying to solve business problems with the help of data, right? If the data is very huge and you want to manage that huge amount of data, big data will come out of the picture. I get your point. If the data is very dirty, or the data comes from multiple sources, maybe the data, so for example, one of you said that you're working with Oracle EBS. Let's say the data source is Oracle's database, the data source is a website, there is some data that is residing on website, data source is some sensor data, and you want to combine all of these three together. So then data handling comes to the picture, SQL will come to the picture there. Do you understand what I'm trying to say? And if the data is very nicely there in your database systems, and you just want to run models and make decisions, then you directly go to analytics. Do you understand? So that's how they're interlinked. Does it make sense?
Yeah, thank you. Got it.
Yeah. Any other question, anybody? I know there are some economics folks, they're not asking questions, guys. Any questions that you guys have? Maniman, Manaz, Nandini, Shweta, Naveen. Any questions? No? Already. Now, let's move towards the last section that I want to talk about, and then I'm going to open the discussion. I open the session for questions. Actually, so any career-related question that you may have. So, what are the things that interviewers like to focus on? Is my favorite part, right? What are the topics that interviewers like to focus on? And I picked these things based on some research that I did. Search and aggregation skills, hypothesis testing, scenario analysis, optimization, reinforcement learning. What are these, right? Search and aggregate, I give an example. Say, for example, you want to find out what are the top, in fact, I've got some examples written here actually. Search and aggregate would be, when did my last user make their last purchase, right? For example, you run a website portal, right? And you want to find out when was the largest user that you have had made the last purchase, right? Why would that be interesting? Why would that be an important thing for you to know? The reason why it would be an important thing for you to know is that if the largest customer has not made a purchase in the recent time, maybe you want to reach out to that customer with some special offer. Do you understand? So how do we do that? Again, you do that using SQL mainly. Okay, And you can also do that in R and Python and Excel as well, but SQL becomes, or a structured query language becomes an important skill set to have there. Okay, very English friendly, very easy to learn, but extremely important. Hypothesis testing. Now, what is hypothesis testing? There are, again, economics students, they will tell you very easily what hypothesis testing is. Hypothesis testing basically means that it tells us if our data applies to new situation or not. What basically it means is that if something is true for one sample of data, is it also true for the other sample of the same population? Meaning, imagine uh, discounting of smartphone drives lot of sales in India. Discounting, 5% discounting or any kind of discounting in smartphone drives lot of sales in India. Does it do the same thing? 5% discounting, does it drive lot of sales in Malaysia as well on the same phone? If it is true, then we will say hypothesis testing is valid. That means the hypothesis that we made, that yes, if we give 5% discount, it will drive the sales by at least 20%. Right? If it is true in both the market, then we'll say, okay, this hypothesis holds true. Right? So hypothesis testing helps you to establish your experiments. Okay, very old technique, very widely used. Okay, scenario analysis. What would happen if we raise the price of a product by X, suppose, or what would happen if we reduce the price of a product by Y percentage? Would it impact the sales or not? Optimization. What is the shortest route to go from point A to point B? A lot of all these Swiggy, Ola, Uber algorithms, Google Maps algorithm are on the basis of optimization. How do we reduce our food delivery cost? Okay, so Swiggy has hired a couple of folks from Ivy, and they have given a lot of good projects as part of the interview process, and we saw them asking the same question, which is how do we determine, how do we reduce or minimize our product delivery cost? Very important question to ask here. Optimization. Reinforcement learning means basically that you try and optimize the data, and you try and see that if it is if it is the most optimized way of achieving the outcome in real time. For example, you're playing a game, right? What is the right time to click to survive is in a game of Flappy Bird, right? Or what is the right time to kick that ball in a game of FIFA online game, right? So that is reinforcement learning. That means the model is trying to learn by itself, okay, and trying to optimize its result. So in statistics and machine learning, as I said, I've been saying since the beginning of this discussion today, classification and regression are the most important thing that we discuss. We have seen some examples of classification and regression as well. Is this A or B? What is this, guys? Is this classification or is this regression? Is this A or B? Is this classification or is this regression? What do you guys think?
Classification.
How about others? I want everybody to participate. Soham, Shweta,
Classification,
Nitesh.
sir.
Classification, Mehnat says. Sayantika, what do you think? Shweta, what do you think? What do you guys think?
So it might be classification.
Okay, Soham says. All right. All right. Classes, right? Is this A or B? There are two classes we're talking of, right? So that is why this is a classification problem. Will the customer default on a loan or not default on a loan? Is this good or is this bad, right? So since there are classes, categories, so that is why we call it as classification problem, right? Relationship between X and Y, meaning if we give more discount, does it lead to more sale? If discount means more sale, that means there is a relationship between them, and that's a regression problem. Here, what will be the dependent variable, guys? And what will be the independent variable?
Dependent
do you
is
guys think?
sale.
Dependent is
It's
Yeah, dependent is
sale.
sale and independent
Discount
is
is
sale.
independent.
Dependent is sale and
That's right, Santika. Very good. Now, so that's that. Other technique that is very popular among interviewers to ask is feature selection and dimensionary reduction. Now, what is the meaning of this? What are the most important variables to predict the outcome? Meaning, let's say house prices, right? We discuss house prices. Now, house prices is a function of, we said that house price is a function of a lot of variables. Remember, we said house prices is a function of, oh, okay, it went away. House price is a function, you said that house price is a function of locality, the size, the amenities, um, uh, the size, amenities, localities. What are the other parameters that you guys remember?
Number of rooms,
Bedrooms.
Number of
the
rooms.
Sorry,
number
number
of
of rooms.
floors,
number of people.
Number of rooms. Not number of people, but number of rooms, and so forth, right? There were so many variables that we said that yes, house price could depend upon all of them. But let's say there are 30 variables in this problem set, right? 30 independent variables, 30 of them. Variables meaning 30 columns, 30 attributes, right? But we say the feature selection says that, you know what? Not all these variables are equally important. We have to figure out that what are the most important variables that have huge impact on house price. Huge impact. Now, your common sense would say what? That house price is a function of, the most important variables would be what? You have mentioned a lot of variables, but what are the most important variables that the house price would depend upon? The two most important variables that it would depend upon, or two or three. What do you think? What do you guys think?
Maybe three. Size,
Which ones?
area,
Size,
number of,
of course.
yeah,
Size.
number of rooms.
Size would actually take care of number of rooms. In fact, so either you take number of rooms
Okay,
or you take the size.
square
Or
feet.
locality. Locality.
Locality, excellent. What else?
And
And maybe,
amenities as well.
maybe age of the building.
Yeah.
Right? Suppose these are the three most important features or independent variables. Features are nothing but independent variables that which determine the house price. So feature selection says, or dimensionary reduction says, that out of all these hundreds of features, or 50 or 70 or 500 features or columns or attributes that we have for any data, what are the most important features that we should consider? And that's a very big science. It depends on business requirement, as well as it also depends on little bit of statistics, right? So we do multiple tests here, and then we figure out what are the most important variables that affect the final outcome or final dependent variable, and we consider those only in the model. We don't consider the rest of the things. Does make sense, guys? Then clustering. Can I categorize my data? We have seen some of the examples. Anomaly detection, meaning is this observation, so are there any outliers? Is this observation weird, right? So do we reject all anomalies, or we say no, let's try and analyze that anomaly. Why is this a anomaly? Can we do something about it? What can we do? Right? Now I'm going to actually give you some scenarios, some questions, and you tell me which out of these statistics and machine learning algorithm that we will use in order to solve that particular problem. Okay, got it? Look at this. The first question says, is there a relationship between time spent and the sun and the height of a planet? Is there a relationship between the time spent under the sun and the height of a plant? What do you guys think?
yes,
Yes,
sir. There is a relationship.
if it is
Okay.
more sunny,
Okay, so what kind of a problem is this? Is this a regression problem, classification problem, hypothesis testing? What kind of a problem is this? Anomaly detection?
Sir, I guess it will be a regression problem.
Regression.
Why, Sayantika?
So I feel that like there is a relationship, like we are trying to show the relationship between like time spent on the sun and the height of a planet. We are trying to like um
So this is like X and this is like
the
Y.
x, and this is like y, so we are trying to show the relationship. So regression, as we have seen that in regression model, we always try to show the relationship. So this is the regression
Absolutely
model.
right. Absolutely, you're right. Because there is a relationship that we are trying to show, and hence it is a regression problem,
Yes. Yes.
right? Will this air conditioner fail in the next 3 years? Yes or no? What do you guys think?
Classification.
Hypothesis.
Sir,
No.
it depends actually.
Tell me, Soham, what does it depend upon?
It depends upon the quality of the air conditioner or
No, no, no. I understand,
and
but my
which
question is this a classification problem or a regression problem?
it's a classification problem.
Because there are two classes, right? Two categories. Very simple. So it's a classification problem, right? How about this? Which animal is in a given image? So this is a binary classification problem.
Hello, sir.
Yeah,
If
Nana.
I put it in this way, like the air conditioner depends upon some variables. Like if I
No,
put it in this
what
way,
what of air condition depends upon which variable?
like
If you say
the
the temperature of the air conditioner or the
or its
life of
part.
air conditioner depends upon XYZ variables, then that would be a relationship or regression.
Yes, sir. But if I say that it depends upon its parts, like if it is not, it's a good part or a bad part, but its quality also. Like if I put it in this way, like then I can show a regression.
No, so then the question would be different. Then you are
Okay,
saying
sir.
the age of air conditioner depends upon what?
Okay, sir. I got
You
it, sir.
understand? But the
Yes, sir.
question will
Thank
not be will the air conditioner fail or not.
you. Okay, sir. I got the difference. Thank you, sir.
Got it? Now see, I tell you one more, okay, practical scenario, okay? For a bank, right? Suppose you are a credit risk officer in a bank, and your role is to decide whether to give a loan to somebody or not to give a loan to somebody, right? Now let's say an application comes to you and you say that okay, this guy has applied for loan. Now if I look at past data of similar customers, right, they have a 80% probability that they will not fail on the loan if the loan amount is less than 10 lakhs, right? So will that be a classification problem or a regression problem? Did you understand my question? I'm a credit risk officer and I'm deciding whether a person will default on a loan or not. Is that a classification problem or a regression problem?
The classification.
It's a
Classification.
classification problem, है ना?
classification.
But now let's change the question a little bit. Let's say I'm a marketing officer in the bank and I want to target high income customers with different strategy, middle income customer with a different campaign, and low income customer with a different campaign for some kind of insurance product that the bank is trying to sell, right? So what I would then have is that I have to predict what is the income of my customers. What is the income of customers? Now income is a continuous variable. It's not a categorical variable, right? It's a continuous variable, meaning my income can be $10,506 per month. or 5 lakhs rupees per year, or it could be 5 lakhs 25 rupees. So it's a continuous variable, right? So, and my income would depend upon my age, my experience, or my qualification, my locality, whether I'm, living in a X area or Y area, or whether I'm working on X company, Y kind of companies. So my income, it depends upon all these. So this becomes what kind of a problem? This is a regression
Regression.
problem, right?
Hmm.
So you see,
Regression.
the data may be similar. The data may be in fact same. But my credit risk, as a credit risk officer, I'm using the same data to make a different judgment. And as a marketing officer working in the same bank, using the same data, I'm making a different judgment. And I may use a different technique. Does it make sense, guys?
Yes, sir.
All right. So which animal is in a given image? This is also a what kind of a problem statement, guys?
It's a regression, sir.
No, Shweta.
The
It's a
Which animal
Class,
no.
is in a given image?
classic, it's a
Unsupervised.
classification.
Problem, right? It could be a cat, it could be a dog, it could be a monkey, it could be, I don't know, lion, right? So these are classes, right? So it's a classification problem. What is the likelihood that the customer will buy?
Regression.
Hypothesis.
No,
the
not hypothesis.
classification problem.
Again, it's a classification problem. Whether he'll buy or not buy. Does it make sense, guys? Is this bank transaction fraudulent?
So it will be a regression problem.
The regression.
No. The outcome
Classification.
of this is yes or
Yes or
no,
no?
right?
Yes,
So
sir.
it is classification, but fraudulent, right? So there is one more technique that we spoke about, anomaly detection, right? So it is one of the classification technique only that we are detecting anomaly, because fraudulent, right? Most of the transactions are not going to be fraudulent, right? I mean, 99.9% of transactions are not going to be fraudulent. 0.1% transaction would be fraudulent. So classification, however, anomaly detection are the types of classification. What factors best predict electricity demand?
The
What is this?
regression.
Regression, sir.
Regression.
Yeah, it's a regression,
Regression.
right? What are the key differences between apple and oranges?
Classification.
No.
Classification, sir.
Think. Key differences.
Oh, yeah, regression. There are many types of differences. Yes. Regression, sir.
It's like I'm trying to say that these features are of apple. That apple looks red in color most of the time, red or green, and the shape is little more T-shaped, right? And the weight is X per unit, right? Whereas orange is orange in color almost 100% of the time, and it is much rounder, right? So these are the features which are describing orange, and these are the features which are describing apples, right? So this we
Sir,
call
is
it
it
as feature selection.
cluster? Oh, okay, sir.
Feature selection. I get your point. What are the features which describe an orange? What are the features which describe an apple? Now, last, what combination of sensors? Okay. In my HVAC system, HVAC is your air, like air conditioning system in large buildings, right? So you can see high volume AC systems. Best displays the overall health of the system. What factors in my HVAC system best display the overall health of the system.
The features selection.
Absolutely right. Ramesh, why did you say feature selection?
Yeah, we're trying to identify the combination.
Yeah, the most important factors, right, or the features which best describe. Best meaning the most important one. I get it over. Does it make sense, guys? Clear, guys?
Yes, sir.
So you would see that there are 3-4 techniques which help you to solve a lot of business problems in data science world. Okay, so if you master these 3-4 techniques very well, right, then you will see that you have kind of become 90% data scientist. Okay, already, guys. So I'm kind of done with what I wanted to cover today specifically. But now let me ask you guys what questions that you guys have which I can address. And if you guys can't think of question, I've also got questions basis this is my past experience of talking with a lot of folks. So what questions that you guys have? What questions, guys? Any questions that you guys have? If you're not, I'm going to give you my email ID and my phone number as well. Feel free to reach out should you have any questions. I'm available on WhatsApp, maybe a little delayed in response, but I'm there. And if you want, guys, I mean, I would love to be connected with you after today's session as well. So on LinkedIn, if you just Google Pratik Agarwal Ivy, you'll find me on the first link that will come will be on LinkedIn, and get connected with me. I'll be more than happy to get connected with you. LinkedIn is a great platform, much better than Facebook. Is a great platform to stay connected, especially when you are aspiring to do something in your professional life. Okay, it's a great platform, and I'm pretty active on LinkedIn or on Twitter also. So if you want to get connected with me, that'll be great. So any questions that I can address, guys, for you guys?
Yeah, sir, I have one question. Is R and Python will be taken care by same faculty or different faculties?
R and Python with the same faculty or different faculty? It depends upon which batch you go into, Ramesh. One of the other flexibility that we provide is that you can choose your faculty also. Okay. Now, why did you ask this question? How does it matter is my question, and what apprehension you have in your mind. There are a lot of people who know both pretty well. Because again, as I said before, right, knowing a tool is not a big deal. Knowing concepts, the data science concepts, which remain the same across all the tools, that is more important. But tell me, Ramesh, what was the reason why you asked?
Yeah,
I mean, yeah,
yeah. Actually, I'm from a finance background. Okay.
yeah,
Uh, yeah, I have gone to one session from Farooq. I'm
yeah,
most comfortable with his lectures. Even
yeah,
non-programming and non math background also can understand easily.
yeah,
That's why I feel
yeah,
comfortable with him. That's why
yeah.
I'm
So
asking.
he does both together. Generally, whichever faculty that you align, that faculty will do both the tools generally. And again, you can choose your faculty also. That's not a problem. One of the flexibility that you get with us, I mean, a couple of flexibilities you get with us. One, you can choose your faculty. That's one. Second, you can choose to do the program online, You can choose to do the program offline. Offline, of course, once the COVID situation improves, then we have offices across the country. You get recorded, whether you do online or you do offline, you get recorded classes, right? So you can always revise, and you can also, the third option is you can do self-paced, meaning you don't even have to, suppose your schedule does not allow you to attend the classes on structured days. So what you can do is that you can just get access to self-paced classes. Okay, in self-paced classes also, I'll just give you a quick demonstration. um, So for example, this is a platform that we use. You will see, so we give you access to learning, our learning management system, whereby you will see all the topic wise concepts are there. So for example, so SQL, right? So all SQL class videos are there, Python, machine learning, so all that is there. SQL materials, right? So all the materials that are used, reference materials, all are given soft copy. All the assignments, you can see so many assignments which are there. Again, the videos here. So if you want to do self-paced, or if you do online or otherwise, whatever, you get access to something like this. All the case studies are there. So case studies and projects are very, very important, and we take them very seriously. So you will work on a lot of projects and a lot of case studies. So you get access to something like this, so that everything is structured. Doesn't give you any, there's no experience difference in whichever mode you do the classes. Okay, any other question that anybody has?
So Durgesh here.
Yeah, Durgesh.
As per the syllabus I've seen, there are statistics there, but in statistics there are major terms are missing, like central limit theorem, and
No, I mean,
for
terms don't go back. So central limit, without central limit theorem, you can't do descriptive analytics. I get a point.
okay,
Even if those terms, some of the basic, I mean, so some of the things that are assumed, I mean, I'd be surprised if those are missing, however, must be mentioned as descriptive statistics or descriptive analytics. I mean, what happens is, see, there are, I don't know, I mean, we spend 200 hours in a program. There are so many things that we do, and it's very difficult to put everything into curriculum, right? So some of the topics are kind of, you can say, summarized. Okay, the umbrella terms may be given. But I mean, central limit theorem, of course, because that's we consider as to be very fundamental, like mean, median, mode, deviations, variance, so without which you cannot do the classes. Absolutely not. So, I mean, just to show you, you get learning management access as well, where the entire course would be listed. So you'll see central, yeah, so for example, this one, statistics fundamental, right? Now, okay, it's not exactly mentioned here. Yeah, no, it's mentioned actually, measures of central tendency and dispersion. I get a point. So the whole section is dedicated to it.
uh, so another question is there. So what about calculus and Linear algebra? It's also not mentioned in that.
But it's not mentioned, but without which you cannot do it. Again, it's one of those things. It's like fundamental of it.
So okay, I'm just new about this, so I'm not
Yeah,
just
yeah.
aware of it.
So see, the idea is that when we do the, so this is the actual curriculum, right? I mean, but if you put each and every topic, it just becomes a little too confusing for people, So, but there are so many things that we do. So again,
Okay.
so the idea is, Durgesh, you do not have to be worried about a certain topic. That's our worry. And we are famous in the industry, and we spent 12 years in this industry. We work with some of the largest corporate houses in this industry. The reason why we've been working in this industry and we are famous is that we are very content focused and student focused folks. I mean, very strongly person. I mean, I'm one of the co-founders. I mean, you have my personal number, my email ID, and I carry only one number. So you have clear touch. So if you find that no, there should have been a topic that should have been covered, right, and it was not covered for XYZ reason, Because you see, what happens is when we design a curriculum, we of course design a curriculum basis what we see, what our corporate clients are looking for, what we see, what is being used in the industry. But if there is something new comes along, we do not mind adding to our curriculum. So don't worry about that. Okay, I mean, I did not learn. Making you learn is our prerogative. I mean, you don't learn
Yes.
with one faculty, we assign you to another faculty. You don't learn in one way, then we are willing. As long as you are willing to learn, there are a lot of opportunities we give you to learn.
So can you mention the faculty in Mumbai? Because will reside in
Farooq,
Mumbai.
Farooq is there. Farooq is one of our famous faculty.
Farooq
And you
Hashmi.
see, yeah, Farooq. I mean, Farooq Hashmi. I mean, you see, what is happening is because of COVID, right? Now the faculty members are not very location specific. So you'll always find some faculty members doing some modules. For example, you'll always find me, Ishani, Farooq. There are some of the folks who always do some of the other modules in all the batches. Okay, especially in COVID time, what has happened is that no faculties are really attached to one particular center per se.
Yes, sir.
Yeah.
Sir, I have a question.
Yeah, man.
Sir, can you please tell me the difference between data analytics and business analytics?
Yeah, I mean, good question. Again, it's very subjective, right? I mean, we've had a lot of people who actually are doing pure data science role, playing pure data science role, but the designation says business analyst, right? Because you see, earlier the most frequently used designation for people who are working in analytics was business analyst because they were solving business problems. I get a point. My batch, I remember when they were hired, so their designation was business analyst. Then the second designation was business consultant, right? So to tell you the difference, I mean, really hardly any difference. I mean, data analyst. So let me go to that slide, which spoke about this particular slide. So if I really have to describe the difference, right, between a business analyst and a data analyst, a business analyst would be a person who would be doing these two things um, very often, okay, very, very frequently. And a data analyst would be a person who's more in the data side and not really applying a lot of statistical algorithm, but more focused on working on the data at the data layer. Lot of tools, lot of data cleaning, because again, as I said, 2/3 of the time goes in here. So you really require people who are great with the tools, right? So a lot of companies call these kind of roles as data analysts, and a lot of companies call the combination of this side and this side where you're actually solving business problems as business analysts as well. But again, these terms are very interchangeably used. Manas,
Okay, sir, got
you
it.
should always go through the job description.
Yes, sir, only I get confused because somewhere it is written business analytics, then
Yeah,
somewhere it
yeah,
is written
don't.
data analyst.
अरे हमने in our career, see, I've been associated with this industry for the last 16 years now. Terms, I have seen them changing so frequently that it's very difficult to keep a track, right? So we don't get odd, or we don't get confused with the actual roles. We say that, okay, what is it that you do? Tell us. I mean, we always say, so a student says, sir, I got a role as a data scientist. We say, all right, great, congratulations, but tell us the actual role that you have to play. And then, many times we realize that a very talented person, right, because that company is there and who's trying to fool the student and saying that, hey, you know what, this is a data scientist role, but what they're really making them do is just work on some Excel data, right? So, I mean, what we try and, so that's what you need to do, right? You need to go into the depth of the JD, exactly what you will do. Don't get fascinated with the designation.
Okay, sir. Sir, since I'm a fresher, I'm a bit confused. Like, if we learn coding like in R or Python, and what kind of questions that we might face in an interview
So
regarding
again,
these?
don't worry about that coding bit. Okay, so coding is the easiest thing that we have come, and that's a question that I always get. That is why I mentioned here. I think, yeah, do what extent coding is important in data science. You see, what happens is that here you are you are a super user. You are a power user of these languages like Python and R and SAS and whatnot. You're not building these languages. A software coder would be a person who would actually write SAS, who would actually build R, who would actually build Python. You're not becoming that. So don't expect that they will ask you those kind of questions. They will definitely ask you that, okay, what packages would you use to probably do statistical modeling in Python? So which is scikit-learn, right? I mean, and how do you do data import and export? So which is pandas. How do you do number calculation, numpy? So those are the things that, I mean, if at all they ask you, then they will ask you. How do you write basic parameterized function in Python? So those are the things that they see. Coding, any above average intelligence person, my 7-year-old daughter is learning coding. Okay, any above average intelligence person can learn coding because coding is very logical in nature. It's very well defined. What is most important? What is the most difficult thing to learn, as I said before as well, is this logical thinking. That is freaking the most difficult thing. And all the good interviews, final round, the VP or the senior most person would ask you these kind of questions, and they will throw you out if you falter here, even if you've done everything good in technical rounds. This becomes one of the most difficult subject to build skills on. I take this subject personally. I have a subject called as analytical problem solving, and I take it personally, but I know that I find it the most difficult. I mean, I do SQL also, I do data modeling also, but there I know that 1 + 1 is always equal to 2. Here in logical thinking, each problem may be a little different from the other. So how do you exercise your brain to think in different ways, and that too quickly? How do you build presence of mind, right? One of my students was asked how many so the question was, so in his resume he had mentioned that he's a avid cricket fan, and he likes to really follow cricket statistics and whatnot. So the interviewer said, hey, I see that you really love cricket, you're from Delhi, so have you gone to Firozshah Kotla, which is the famous cricket stadium in Delhi? And the guy said, yes sir, I've been to Firozshah Kotla 5 times. He said, oh, very nice. Tell me, how many grass pellets are there in Firozshah Kotla? How many grass pellets are there? Can you imagine? That was a question that was asked to a cricket fan. Now that guy, okay, sitting in the interview is pinging me on WhatsApp saying, sir, I don't know, I mean, how to answer this question. Yes, I love cricket. I've been to Firozshah Kotla, but I've never counted the number of grass pellets in Firozshah Kotla. But there was an approach, right? I mean, if cricket fields are oval in nature, there is a 22 yard this thing, and then there are almost 30 yards. And if you know that if you're really a cricket fan, when a batsman hits a six, general size of the boundary is 70 meters, right? So if you know that, and you know that the pitch size is 22 yards, where there is no so 22 yards by 2 yards where there is no grass. So if the radius is 70 meters, so pi r square will give you the area, right? And if you subtract this pitch area, then you'll get the green area. And in the green area, you can easily imagine that in a square inch, how much grass pellets would be there. By this time, see, again, nobody is looking for a accurate answer. They're looking for an approach, that whether you thought of this approach. Now it's about practicing your brain. It's like, so that is the most difficult thing. Don't worry about coding. I mean, we are very, very good, we are very confident. Coding is something that we make people learn. What is, I mean, logical thinking, and then statistics and these probability, these are more difficult things to learn than anything else. Good question. Any other question, guys?
Sir, in this course, everything instructor live or any self-paced
Instructor live.
included?
No, everything. No, instructor live, online live, unless you opt for a self-paced. Otherwise, 100% instructor live. And that's the power of this course, right? I mean, we want you to learn with the instructor. We want you to just, for example, today, right? I mean, you are asking question, I'm answering, and we have all the technologies in place, and it's very, I mean, we have mastered that art. So we love this experience whereby we can communicate with the students one-to-one. So that's what is the power of this course. We don't believe in a lot of recorded lectures. Recorded lectures are good for people who are significantly motivated And if you really do not have time, then it's a different thing. Then you can go through the recorded lectures in self-paced fashion. Even there, we provide faculty support. So yeah, it's 100% live, each and every course module, unless you opt for something. Suppose you say that, hey, this module I want to do in a self-paced fashion. Some students do that. They they don't have time to attend the live classes, then they do that. But we encourage people to attend live classes.
And duration of this course to complete?
Well, I mean that our relationship managers will tell you, because different courses have different durations. Some are 150 hours, some are 200 hours, some are 300 hours as well. So that depends upon the course package that you take. And again, you have an option of doing weekday weekend combination, or just weekend combination. So that determines the entire schedule. But we have flexibility. You have multiple batches, multiple days that we run the classes. So different people have different preference. Some people want to do it in fast pace, so they take like 4 to 5 classes per week. Some people want to do it in a regular little relaxed pace, so then they do only the weekend classes. Depends upon the person as well.
The weekend batches are only on Sundays or Sundays, both.
Saturday, Sundays, both. Now, if you have a problem on Saturday, then you can we upload the recordings of the class on that same day, so you can actually refer to the recordings as well.
What are the timings?
Different timings are there. 11 to, so 8 to 11, 11 to 1, 1 to 3, 3 to 5, 5 to 7. Different timings are there.
So there are
Only 2
timings for like after 4 p.m.
Yes, 5 to 7.
Yes, yes. Because we have
Because
alternate Saturdays working. So most
Like full day working, or like half day working?
no, sir, Saturday is a half
Saturdays
day. My
half
shift
day.
till 4 p.m.
Yeah. So you can take a 5 to 7 batch, 4 to 6 batch. There are
Okay,
multiple
sir,
times.
5 to 7. Convenient.
Faculty will be the same, which I have chosen.
Yeah, again, you see, the more constraints that you provide, right? So you may have to wait a little longer. That's the only thing. See, all faculty, you can take the demo. You have sample recorded classes of all these faculty. All of them are pretty good. First, everybody follows the same content, and all, we do not have anybody who has less than, I've got 15 years, 16 years. Ishani's got 16, 17 years. Farooq has got 7 or 8 years, or 10 years, I think. Arpendu has got 8 years. So, all of them have significant amount of experience. The more constraint you provide, the longer you may have to wait. So you say that, no, I want 5 to 7 with X faculty only. So then you just have to wait for that slot to get empty. But remember, one faculty doesn't do the entire course. That is impossible. Okay. For example, I'm a SQL expert. I've worked on Python and R as well, SAS also, but I consider myself to be stronger in SQL. So I prefer to do data modeling classes, SQL classes, Excel classes, dashboarding classes. Farooq is more comfortable in predictive modeling and deep learning models, so he takes those classes in Python and R. Similarly, Ishani is great in visualization, data visualization, and VB automation. So you always have a package, a group of faculty who specialize in their own specific subject areas. Because you see, data science is a mixture of multiple skills, right? To expect that one person is an expert of everything is wrong. Are you getting point? All our
Yes.
faculty, okay, all the faculty have simple, has a rating of 4.5 plus out of 5. And this is something that you will also realize that after every class lecture, or every couple of classes, we send a feedback link, and that is taken very seriously. So it's like Ola, Uber sends you the feedback, right? And each feedback is taken into consideration as to what is going wrong. And 90% feedback is very important. You see, our pedigree, we all come from non-academic background. We all work with large companies. I mean, you imagine all the companies I'm talking about, ITCs of the world, Tata Steel, Capgemini, Cognizant, HSBC, Honeywell, Accenture. I mean, these are Tesco. These are extremely large and very, very quality focused companies we work with. So when these guys work with us, so we have to match their quality because our payments are linked with their quality. The same faculty, the same consulting team, I mean, the same team, the same content we deliver here. So we have been trained to deliver strong quality. See, in education, you can't do a bad job. It's like medical science, right? You can't be a bad doctor. If you're a bad doctor, nobody will come to you. So it's the same concept. I mean, we take it very seriously. Faculty, content, these are our job. You don't like anything, you tell us, and we'll be more than happy to do anything that is possible. Your job is to attend the class sincerely. Your job is to do the assignments, the case studies, the projects in the schedule that we tell you. After every class, we give you a case, we give you an assignment. After every module, for example, SQL is a 30 hours, 25 hours class module. It gets over, we give you 3 projects. Look at this, I think I showed you, right? Now, suppose these are case studies. All these are interview case studies. I mean, asked by Flipkart, Accenture, Ola, Taxi for Sure, right? Harry Potter. I mean, all these are interview case studies. We give you due dates as well. On the right side, you can see the due dates. Due, when they were due, right? What we expect from you is that you finish these cases, these projects within the due date. And if you're not doing so, that is where you are not keeping your side of the bargain. I get a point. These projects are there, right? And you got to work on these projects. Swiggy, I mean, these are all live projects that we have given. Case studies and projects are very live. And then you'll see that there are assignments which are topic specific. Each one of them comes with some kind of due date, right? And we have put a lot of intelligence into designing these assignments and case studies and projects. And we give you ample time as well. Remember, we'll not overload you, but you got to stick to the schedule. If you're not doing your part. That's what you as a participant of this program have to ensure. Rest, leave it up to us. All right, guys, it's almost 9 o'clock. We have taken 10 minutes extra. My number, my email ID is given in the chat window. Please feel free to reach out to me. Also, if you Google, you'll find me on LinkedIn and on Twitter, Pratik Agarwal Ivy. So please get connected with me on LinkedIn and Twitter. I'll be more than happy to accept your request there. Plus, last thing I would suggest you guys to do is that, if you go to YouTube channel, we have a channel on YouTube called as IvyProSchool. If you just Google youtube.com IvyProSchool, you'll get there. What you get there is that you get very interesting, relevant topics covered for free, right? And very good speakers who's spoken about, and some of the student reviews as well. I mean, like people who have experienced the program. So very good things, how to choose data analytics, your data analytics career, how to become a data analyst career, how to, if you want to just do a little bit of small classes on SQL, Python, data structures, Python for beginners, right? I mean, so you can get started even without enrolling. I mean, if you're even if not enrolled, you can do that. There is great dashboard analysis that one of our students only has done. Very nice job. You want to see how interviews happen, you can see something like this. So it's a great place where you can actually see, you want to see an overview of linear algebra, you can see, we've spoken about regression a lot, so you want to see what those are, you can see them from here. So very good things, so if you want, you can, subscribe to this channel. There's a subscription option and you can see and be connected with us. Thanks a lot, guys. Thank you. It was pleasure connecting with you all today and hope to see you again. Feel free to get connected with me, guys.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you. Bye-bye. Take care, everybody. Good night. Stay safe.